Hello friends, welcome to online lecture series. This is the third lecture of your unit number 2 in physical chemistry, that is phase rule. Okay, so in our previous two videos we discussed about what is the basic term of phase, components, constituents and degree of freedom. Okay, so in this lecture I will explain presentation of three component system, how to present three component system in phase rule. Okay, so first one was, it is very difficult to explain three component system, but scientists Stock and Rusbaum gives easy method for three component system. Okay, so suppose in your example three components are present. At that time, how you represent all the three compounds by graphically? It is not simple. It is very difficult to explain three component system, but two scientists, first one is Stock and Rusbaum, gives easy method for representation of three component system. Okay, so first one is, this is the three different triangles. First triangle is for component A. First triangle is for component A. Here we can see that the value 0, it means 0%, 20%, 40%, 60%, 80%, and last one is 100%. Okay, so figure 1 for component A. Here we can see that at the left angle of triangle, that is capital A. Here the value of capital A is 100%. It means if only A is present in your system, then at that time the value of, suppose in beaker you have only one component, that is A. You have only one component, that is A. So in this system only one A is present, and that is composition is 100%. Okay, so we denote this A in left side of the triangle. If two A and B, both two are mixed at that time, suppose A is 80% and B is 20% mixed in your system, at that time the value of A composition is 80% and the value of B composition is 20%. So at that time, here this A is indicates at this line. This point indicates the value of A is 80%. This point indicates the value of A is 60%. This point indicates the value of A is 40%, and this point indicates the value of A is 20%. Okay, so this is the only component A. This figure is only for component A. Here we can see that the value of A is 0%, 20%, 40%, 60%, 80%, and 100%. Okay, so in next figure we can see that this is the for component, this one for is A, this figure for component B. Okay, so composition of B is written as 0%, 20%, 40%, 60%, 80%, and last one is 100%. This point indicates, it means right angle of the triangle. Here we can see that this angle indicates the value of B is 100% and this angle indicates the value of A is 100%. Okay, so here the value of B is 0%, here it indicates the value of B is 20%. This point indicates the value of, it means composition of B is 40%. This point indicates the composition of B is 60%. This point indicates the composition of B is 80%. And similar for C. This figure for component C. Okay. Here we can see that it indicates the value of composition 0. C is 0%. Here composition C is 20%, 40%, 60%, 80%, and 100%. Okay. So in this example, we take two components. First one is A and second one is B. Here the value of composition A is 80% and the value of composition B is 20%. So we denote two different points. First one is for A. A is 80%. It means here A is 80% at that point. A is 80% at that point. So this point indicates the value of A is 80% and the value of B is 20%. So composition B is 20%. Okay. Here in this case, two components are given. First one is A and second one is B. So the composition of A is 80% and composition of B is 20%. So denote these 2 points in triangle. Here A is 80%, so A is 80% and B is 20%. Okay. And suppose in our next example, I take next example of 3 component system. Okay. Suppose in this case 3 components are mixed together. First one is A, second one is B, and another one is C. The composition of A is 25%. 40%. Okay. Composition of B is only 40%. Same as A is present in 40%, B is present in 40%, and C is remaining is 20%. Okay, so here we can see that in our system 3 components are mixed together. First one is A is in 40%, B 40, and C 20. Okay, so now I represent A is 40%. So this point indicates the value of A is 40%. Okay, and B is also 40%. So this point indicates the value of B is 40% and the value of C is 20%. So the value of C is 20%. So different 3 sides of triangle. First one is this side is indicates for A, this one is for B, and this one is for C. Okay, so representation of 3 component system. It is not easy. It is very difficult to explain 3 component system, but two scientists, first one is Stock and second one is Roosboom. Stock and Roosboom gives easy method for 3 component system. Here 3 different triangles are given. First one is for A, second one is for B, and third one is for C. Okay, so different composition are also given. A is 0 at that time. Suppose A is 0 at that time, we indicates this point. This point indicates the value of A is equal to 0. This point indicates the value of A is equal to 20%. This point value of A is 40%. This point indicates the value of A is 60. Same as B, same as C. Okay. So in figure 1, when component A is 100%, it means only one component is present in your system at that time. Then it is represented by point A. Here this point is A, this is point B, and this one is point C. Okay. So represented by point A at a corner of triangle. Here we can see that corner of this triangle indicates the value of A is 100%. And when A is mixed 80% with another components, A is 80% with mix another component. At that time, line drawn from 80% to opposite side. At that time, line drawn from A into opposite side. Okay, it is shown in figure. Same as in 20%. Suppose A is present in 20%. At that time, 20%. This point indicates 20%, and line drawn from opposite side of the triangle. Okay. So same as representation of component B and C, same as denoted in figure. Okay, so first one is, this is for components A, this one is for components B, and this one is component C. Okay, here this angle indicates the value of this angle indicates the value of components A is equal to 100%. Okay, so this line, it means this side indicates the composition of A. This side indicates the composition of A. This one is for composition of B. And this one is for composition of C. Okay. Suppose A is present is 60% at that time. This is for A. This line indicates A. So this point indicates the value of A is 60%. Suppose B is 80% at that time. This point indicates the value of B is 80%. And suppose C is 40% at that time. This point indicates the value of component C is 40%. Okay. And so this is the simple three representation of different individual compound. Here this figure indicates only components A. This is for individual for component B, and this one is for individual component C. Okay. So now complete representation of three components. How to how to define all the complete three component system in only one triangle. This is the figure number 4. Okay. So here we can see that the value of this corner, it means the value of composition A is 100%. Okay. So here the value of A is 100%. Here the value of component B is 100%. At that time this point indicates the value of A is 0. Component A is 0, B is 100%. Okay. So at this that angle the value of B is component B is equal to 100%, and this point indicates the value of C is 100%. At that time this point indicates the value of C is 100% and B is 0%. Okay. So this one is for C. This point indicates the value of C is equal to 100%. A is 100% at that angle. Okay. So first one is all the three angle indicates pure components. It means suppose A is 100% in your system. A is 100%. It means no any another components are mixed. Okay. Only A is present. A is 100%. It means only A component A is present. No any another components are present in this system. Okay. So corner A indicates 100% of A. So this corner indicates the value of A is 100%. This corner indicates the value of B is 100%. And this corner indicates the value of C is 100%. Okay. So this is the simple and easiest representation. But the credit goes to two scientists. First one is Stock and second one is Rusbaum gives easy method. Okay. So it is very difficult to explain three component system, but two scientists, first one is Stock and second one is Rusbaum gives easy method for a representation of three component system. So first one is this figure indicates components of A, this one is for component B and this one is for component C. Okay. So in figure 1, when component A is pure, at that time pure means 100% A is present. A is 100% pure. At that time this point indicates the value of A is equal to 100%. This point indicates the value of B is equal to 100%. At that point the value of A is 0%. B is 100%, A is 0%. And this point indicates the value of B is 0% and C is 100%. Okay. And suppose only one component is not present, at that time when A is mixed with another components, at that time draw line from A to the another side. Okay. When A is 80% mixed, that time draw line from 80% to its opposite side. So it means here the value of another components is also present and it is 80% at that time. This point indicates the value of C is 20%. Okay. This point indicates the value of C is 20%. Okay. So same representation for components B and component C. Okay. So overall a representation of three components. Now complete representation of three components are given as below. Okay. So first, all the angle indicates pure components. It means here the value of A is 100%, here the value of B is 100% and C is 100%. Okay. So this is the basic easiest representation of three component system. Second point is point number 2. Point of any side of triangle describe binary system. Point of any side of triangle describe binary system. It means here three sides are given. This one is for, this side is for C, this one is for B, and this one is for A. Okay, so point on any side of triangles describe binary system. Binary system means two different components are present in your system. Binary system means two different components are present in your system. Suppose only one component are present at that time, you can say that a single component or one component system. If two components are present at that time, you can say the two component system or binary system. If three components are present at that time, you can say that three component system or ternary system. Ternary means three different components are present in different composition. Okay, so first one is point on any side of triangle describe binary system. Here we can say that this point P. Point P indicates 40% of B and 60% of C. Okay, so first here this point is a point P, and point P means here we can see that the exact position of point P is in B. Here this point indicates point P, and on side of A, point P is not present because line drawn is not on this side. Okay, and in C, this point indicates point P. Okay, so the composition of P, it means P 40% of B plus 60% of C. So it means point on any side of the triangle describe binary system. It means point of any triangle here, here and here. Point of any triangle, side of the triangle describe binary system. Okay, so second one is point R. Here we can see that point R. So first find the exact position of point R. Point R means here, it means this point indicates point R, and this one is also for point R. Okay, so the composition of A is 80%. A is 80%, and the composition of C is 20%. This is also point R. Okay, so point R indicates the composition of C is 20%, C is 20%, and the composition of A is 80%. Here not R is point R is present in B. Okay, so it means point on any side of the triangle describe binary system. It means two different composition are present. First one is point of any corner indicates pure components. It means 100% pure components are present in your system. It means it is only a single system or one component system. This is the point of any side of the triangle is binary system or two component system. And the third point is point inside the triangle describe ternary system. It means point inside the triangle. It means here, at any corner, any point inside the triangle describe ternary system. Okay, so first point inside the triangle describe ternary system. Here we can see that point M. Point M inside, it is inside the triangle, and it is denoted by capital M, and this point indicates ternary system are present. So first one, find exact position of this point. So composition of capital M is 20% of B, 20% of B, because this line indicates composition of B is 20% at this exact position, and the composition of A is 20%. This line indicates the composition of A. This line indicates here the point M are present. Okay, so this point indicates the composition of A is 20%, B is also 20%, and here on C, it means this point indicates the composition of C is 60%. first and second line. It means first and second line. This point indicates the value of composition of C is 60%. Okay, so point M indicates 20% of M A, sorry, 20% of A, 20% of B, 20% first line. It means composition of first line in B figure is 20%, and first and second line, it means the composition of first and second line indicates the composition of C is 60%. Okay, so point inside the triangle describe ternary system. It means three different compositions are present. First point is point any corner of the triangle indicates one phase system, one system, or one component system, or single system. Okay, and point B, point at any side of the triangle, indicates binary system. It means two different composition or components are present in different composition, and point inside the triangle indicates the ternary system. It means three different compositions are present. Okay, so this is the basic representation of three component system. Stoke and Rusbaum gives simple and easiest method for find the exact position of point, any point inside the triangle, at any side of the triangle, at any corner of the triangle. Okay, so it gives simple explanation how many percent A, how many percent B, and how many percent C are present in your system. Okay, so this is the basic and simple representation of three component system. Another method of representation of components is right angle triangle method. Okay, so this method is rarely used to describe all the components. Okay, so another method of ternary system when if two solutes and one solvents. This method is used when two solutes are mixed in solvent. It means suppose this is the H2O and it is A. Okay, so in H2O, if I mixed NaCl and sugar, this is the B and this one is the C. At that time, if two solutes are added in solvents, okay, so at that time this method can be used. So another method is ternary system. If two solutes and one solvent components are present, then it can be represented by right angle triangle. Okay, so here we can see that the value of component A is 0 on point BC. The value of component C is 0 on side AB, and the value of component B is 0 on side AC. Okay, so this point indicates the value of A is 20% and C is 80%. Okay, so this is the basic method for describe three component. It means ternary phase. Okay, so A is 0 at any point on BC, A is 0 at any point of line or side of BC, B is 0 at any point on AC, B is 0 at any point on line AC, and C is 0 at any point of line AB. So this is the basic, and it is a rarely used method in three component system. The main method is Stoke and Rusbaum gives this method, triangle method. Okay, so this is the main, and this is the rarely used when it is used when one solvent and two solute system. Okay, so this is the basic representation of ternary phase, ternary system. It means three different components are present in three different composition. Okay, so in this lecture I will explain about how to represent three components, ternary components. It means three different components in your system. There are two methods. First one is Stoke and Rusbaum method, and second one is right angle triangle method. Okay. So in next lecture I will explain about one page system. Okay, so thank you for watching this video.